Hey guys, so welcome back to your next lesson of catalyst concepts. In the previous lesson, we had learned about how to solve certain numericals that will come across in the chapter. We use the formula that we had learned about work. That is W equals to F into S, which is nothing but force into displacement, making sure our force is in newtons and our distance displacement is in meters, right? Only when we are able to get those two units majorly can we do that, right? We also saw a case wherein we didn't have the force given directly, so we calculated it as F equals to m into g. Okay, so now let's move ahead and take a closer look at these examples of work that we have taken. All right, so I'm just going to try to depict it a little bit in drawing. Okay, say that there is a man standing here like this. All right, and say that he is pushing a big box or something. All right, he's trying to move this box this way. Okay, so which direction is this man going to put his force in? Right, he's going to obviously push the box on this side, and his force is basically going in that direction. Correct? If that is the case, now what is happening to this box? It is going to move probably a few inches, feet, or meters, whatever it is, and then it is going to reach somewhere. Right? Now, I want to see which direction did the object move in. Okay, it went from here to here, which is basically that direction only. Okay, displacement is again from, let's say, left to right for now, as of now. Okay, so if I look at it, my force and my displacement are in the same direction. In other words, what I can say here is that the object is displacing or moving in the direction of the force that is applied on it. Okay, the object is moving in the direction of the force that is applied on it, right? Let's try to take another example. um, okay, so let's say there's another man standing in here. Okay, he has a ball in his hand and he throws it up. Okay, he's going to throw that ball up like that. Okay, and then it will just go flying, reach somewhere. Right, now my question again is, which direction does he put the force in? And that is simple. He's throwing it up, so he'll be like this direction, up. Okay, so I can say that force is in the upward direction right now. All right, now what direction is the displacement in? Okay, which direction is the object moving in? It's also moving in the same direction, whereas the ball is moving from here to here in this direction. So I can say that both my force and displacement are again in the same direction. Okay, so whenever this is happening, which is happens in a lot of cases, this is called as positive work. Okay, positive work. Okay, positive work is said to be done when force and displacement are in the same direction. Okay, that is when we say positive work is done. Very clear identifier. All right, now when this is happening, there obviously makes sense that something about the object is going to be special, right? If you look at it, if I throw this ball, what happens to the speed of the ball? Is it increasing or is it decreasing? Right? Has a ball increased in its speed or decreased initially? Right? I know that obviously when I throw it, it's normally at stationary, it's not moving. But the moment I throw it, it's accelerating at a very fast speed. Right? Same goes with the box. Okay, when I'm pushing it, it's moving. It's because of me pushing only that's moving. Right? We spoke one thing already. When we're giving force or when work is happening, that means some energy is being spent. Correct? Now, the question is that energy being given to that body? Okay, if it is, then is the body's energy increasing or not? Right? Whenever we do positive work, we say that the energy of the body is going to increase. Okay, for example, the ball, right? It cannot go fast unless the energy is increasing, right? So we say that whenever positive work happens, we also say the energy of energy of object increases. Okay, whichever object on which the force is acting, that object's energy is going to increase. All right, be it throwing or pushing. Okay, another example for this would be like putting a book on a shelf. I think that's also an example we saw in yesterday's. Okay, say that you have a book here in your hand, all right, and then you put it on a shelf on the top, right? Say a shelf. You put the book from here all the way to the top. The displacement is happening, but where is the energy changing, right? Because it's still not moving over here. Also, when you put it's not moving, right? However, there is a change in energy, and that change in energy is because of the height increase. Since you increase the height, we say that something called potential energy has increased. Okay, that's something I think you must have learned about in your previous classes. So whenever positive works happen, these two conditions are always there. Okay, that is uh, direction of force and displacement are same, energy of the object has to increase. All right, now if there's something called positive force, it makes sense that there's something on the opposite also, right? Something called negative force, right? Okay, and you can pretty much take the opposite of these two conditions and that will give you what is negative force. Okay, so if I have to talk about a negative force, sorry, negative work, I'm sorry if I was saying force, I meant work. Okay, so if there is positive work, then there is definitely negative work also. Okay, if we take the opposite of this now, force and displacement are in the same direction. What would be the opposite? Is nothing but when force and displacement are in opposite directions. Okay, if this situation happens, then it is definitely a negative work. Okay, for example, uh, you're putting force in this direction, but the displacement is happening in this direction, then that would be an example of negative work. All right, at the same time, we look at the opposite of this. If we say energy of object increase for positive, we can say energy of object decrease for a negative work. Okay, I'm just giving you the definition. We're going to look at the examples now. Because it sounds a little weird. If you're putting force in this direction, why will it move in the opposite direction? Right? Sounds odd. No. But there is something you need to think about. We are not the only people who are using force and doing work in our situations. Okay, let's take this simple example over here of this person throwing the ball. Okay, now say that this boy, whoever it is, he threw the ball. Okay, all the way it went up and reached over there. All right, now we know one thing, that after a certain height the ball is going to stop, right? Why does the ball stop? Why doesn't it just keep going? Okay, it is obviously because it's slowing down, and it is slowing down because it is losing energy somehow. Somehow it's losing all its energy in such a way at some point it's going to stop. What makes it lose that energy is the question. Okay, it is simple. There's only one force that we know that is trying to bring the ball down at the same time we are trying to throw it up, right? And that's very simple. That is gravity, right? We know gravity works in the downward direction. So the moment you throw a ball up, the gravity is constantly doing some work on the ball and trying to bring it down towards the earth. That is why as the ball keeps going up, it will keep slowing down until a point where it completely stops. That's where gravity has done all of the work and taken away all the energy that you gave to the ball. Okay, so here look at this. Okay, this is the direction of gravity. It pulls downwards. Can I say that this is the direction of force of gravity? Right. However, even though force of gravity is acting down, because we threw the ball up, the ball is actually still going up only, right? Up, of course, it's going to stop somewhere, but the point is that even though gravity pulls it down, this is going to still go up until a certain point. This is a classic example of what is negative work. Okay, when the force and displacement are in opposite directions, one is down, the other is up. All right. Very simple example. Another example of this would be if instead of throwing an object up, say that we roll a ball down on the floor. Okay, if we roll it. Now what happens when you roll a ball? Again, it's going to go till a certain distance and stop. Okay, so the displacement is in this direction from left to right, but it is going to stop again because it is losing energy. Now what makes moving objects stop on the floor is something we've learned about in 8th grade. If you studied, there's something called friction or frictional force, right? What this friction will do, it is going to slow down and try to stop an object, and that's again by applying force in the opposite direction. Okay, so we can say that frictional force is opposite, acting in the opposite direction. Okay, we call it ff. So again in this case also work is being done in like negative form, meaning force and displacement are in the very opposite directions. All right, just 2 examples. There can be others. If you can think of any, you can put them down in the comment section below. All right, so that's all for today. I'm going to stop here. Tomorrow we'll come back and look at how can we measure this negative work, and where, like, just take a couple of examples of it. All right, so thank you so much. I'll see you again in the next class. Thank you. Bye bye.